Welcome back. It's about time we added our first endpoint. We'll start with getting the list of target planets that we want to explore and returning that from the API so that we can set the destination of our missions. We're going to be dealing with planets data, and so we'll create a planets collection in our routes. The way we're going to organize this is by creating a new folder for each of our collections, so say planets, and under planets, we'll have a dedicated planets router, which I'm going to call planets.router.js. Here, we're going to take advantage of our built-in Express router. So we need access to Express, so I'm going to import that, require Express. And I'm going to say const planets router equals express.router. And now on this planets router, I can define all my routes. So let's start with getting all the planets. What's this going to look like? Well, it's going to be a GET request on the /planets collection. So we can do planets router.get because it's a GET request, and our collection is going to be under the planets path. We're going to handle these GET requests to /planets with some function that we're going to call getAllPlanets. And we'll implement that in just a second. But to use our router, we need to export it from this module so that we can make use of it in our app.js, which has all of our Express middleware. And remember, our router is just another type of middleware that groups together related routes. And so we're going to be grouping all of our planets-related routes in this file. All right, so let's do a module.exports, and we'll set the exports object to just be this planets router. Now in app.js, I'm going to import that router. So const planets router equals require, and let's get the path right. So it's going to be /routes/planets/planets.router. Looks right. So now we can take this planets router and just add it underneath our JSON parsing middleware with app.use, planets router. Now we're starting to build up this chain of middleware that handles requests as they come into our application. The request comes in to Express, gets checked for the JSON content type, if we're passing in some data, and then goes through our Express router, which handles first all of these planets routes. Now, we still need this getAllPlanets function, and that's going to come from the planets controller. Remember that the controller takes in actions and requests from the user and works with them to update the models. And instead of adding a controllers folder, we're going to keep our controllers next to our routers. So I'm going to create a file for our planets.controller.js. It makes sense to group these two files together because the router is going to be making direct use of the controller. And we don't want to move around too far to find this related code. So now we're going to create our getAllPlanets function. Function getAllPlanets, and it takes a request and a response. And for now, let's keep it really simple. So we're going to have some array of planets. Let's set that to an empty array for now. And we're just going to return or respond with a 200 status code and that array as JSON. So res.status200.json planets. Now, this status code here is optional because Express returns 200 by default, but I'm adding it here so we remember to set the status code appropriately for all of our responses. And you might see some Express code that returns whenever it sets the response. This is just to make sure that our controller functions only ever set the response once. Because if you remember, when we try to respond multiple times, Express will complain about the headers already being set. Because once you set the response, it's locked in. So the return value of our controller functions isn't used by Express. We're just using the return to make sure that our function stops executing and only one response is ever set. Now, you'll see a lot of Express code that doesn't use this pattern, but it's generally a good idea because it prevents unexpected bugs. And you're being explicit about the fact that wherever there's a return is where your function stops executing. So we're going to leave it in there. The more readable your code is, the more obvious it is what your code is doing, the easier your life will be when things start getting a little bit more complicated. All right, and in our simple example here, it's this planets array that's actually our planets model. This is the data as it's being stored in the server, as we're accessing it. So, inside of our models, let's create a file for our planets model, planets.model.js. And now you can see why we might be naming our files in this .model.js, .controller.js pattern. All of these files are related to our planets. And if we're doing a search through our files here, and we see a bunch of planets.js files, well, it won't be clear what the role of that file actually is. Now we can move that planets array into our planets model and set the module.exports to be that array. I know this is a trivial example, but what we're learning here is how to structure our code so that when it is more complicated, things are nice and organized. I've personally used this exact structure on large-scale projects with hundreds of thousands of users. And as an added benefit, we get cleaner, more readable code. All right, so let's update our controller to make use of that planets model by requiring it. So we're going to say planets equals require, and this time we have to go up out of our planets folder and out of our routes folder into models, getting our planets model. And finally, we export our getAllPlanets function. And we're going to return it as an object because there's going to be multiple functions that might be returned from our controller. So it's just going to be getAllPlanets. And in our router, let's make sure we're using the function from our controller. So right here below Express, we'll say const planets controller equals require in the same folder, planets.controller, and that's it. So now we could call planets controller.getPlanets, or we could destructure this planets controller object that's returned from our module over here, and just say that getAllPlanets is a function that's returned from the planet's controller. This is better because now we know exactly what functions and variables we'll be using in this file. Now we could add any other functions in the same way, using them directly when we specify our routes. Finally, let's add our first endpoint to our mission control front end. And we're going to go into that client folder where we had that requests.js file under hooks. So we're going to be filling in the functionality to get our planets. We'll be using the fetch function that's built into our browser. So we'll say fetch, and remember, our client and server are on different ports. The client is on port 3000, and we set our backend API to run on 8000 by default. So we need to specify that when we make our request. We'll say the fetch is to localhost using the HTTP protocol on port 8000 to the /planets collection. And our fetch function returns a promise, so we're going to await the result of that promise. And because our getPlanets function is already async, we're able to use the await keyword. And the rest is simple. We'll set this to our response, const response. Last but not least, we need to return it as JSON because we're returning that JavaScript object in our controller. It's JSON. Or for our planets, it's an array of JavaScript objects. So we just need to call return response.json. And the JSON function also returns a promise, so we're going to await it before we return. Let's move this comment up out of our function. And let me make this a little bit smaller so you can see. All of our HTTP functions are going to be made against our single API. So let's move this address of our API out into a constant. We'll say const API underscore URL equals localhost, and I need to put it in quotes. And then we'll use our template string syntax here to add the API URL before our planets collection. Now, because our usePlanets React code is already calling this HTTP getPlanets function over here, it's time for us to check if everything is working. In our terminal, we'll need to start our server. Remember, our server is an npm package, so we can go cd server and run npm start. And now in this terminal, our server is listening on port 8000, but we need to start our front end, which is being served on port 3000. So we'll create another terminal. I'll use this built-in VS Code feature here. And I'll cd this time into client and run npm start from there. Let's see if our endpoint is being called correctly. If we go to our dropdown, well, nothing's showing up, but we're just returning an empty array, so let's check in our console. We have this warning here because our launches code isn't implemented yet, so that's fine. But if we scroll up, we're getting this CORS error because the origin for our API and for our front end is different. Remember, the origin includes both the URL host name, which is localhost, but also the port number. And so because we're trying to make a cross-origin request, we're trying to get the list of planets from localhost at port 8000 and not from localhost at port 3000. Well, to support this, we're going to need to set that CORS header. Remember the one that looks like access control allow origin? Let's find out how to set this very important header in the next video. I'll see you soon. Welcome back. How do we fix our CORS error? How do we enable cross-origin requests in our API? To recap, cross-origin requests are those that are made from a domain on one origin to a different origin, where an origin is the combination of the site's protocol, the host, and the port. Your origin might be https www.google.com at port 443, or it could be localhost at port 3000. As a security feature, browsers by default block cross-origin requests so that you don't leak your data to a site unintentionally. So Google.com can make requests to Google's servers on the backend, but not to Facebook's servers. Browsers are looking out for us. Now, we can allow cross-origin requests that we expect by sending this special access control allow origin header from the server, which will allow either all requests from any site, if we use the asterisk, or requests only from a specific origin, if we specify the value like so. This follows the practice of whitelisting, which is the security best practice to allow access to a limited set of sites, as opposed to blocking access to only those sites that you might be aware are bad actors, like hackers who are hoping that your users will send your data to them instead of to the appropriate server. When we're using Express, luckily setting the CORS header is just the matter of adding some middleware before our routes. Let's see what we can find in our npm registry. If we search for CORS, the first result here is this really well established and convenient CORS middleware that can be used with Express. Let's see this in action. First, we'll install our CORS package. So in our terminal, we have our client running, and we also have another terminal running our server. So let's terminate our server for now, and I'll clear the terminal before we run npm install CORS. Once it's complete, we can add CORS to our middleware chain. CORS is going to apply to all of our requests. All of our requests are going to follow the same cross-origin behavior, so we'll place it right at the top of our middleware chain. So we need to import CORS. I'll say CORS equals require CORS, and then app.use CORS, which is a function that returns the CORS middleware. It's that easy. However, if we do this, our CORS middleware will allow all cross-origin requests from any site on the internet. We want our NASA API to be production ready and secure. So we're only going to accept requests from localhost at port 3000. which is the origin for our front-end client. The good news is, this is really easy to do with the CORS middleware. We can pass in an options object here, which takes an origin property that we can set to the origin which we want to allow. So in our case, it'll be http://localhost at port 3000. Just like that. If we had multiple clients at multiple different origins, the CORS middleware allows us to support that as well. If we scroll down on their page, there's this option to configure CORS with a dynamic origin, where you pass in this whitelist of domains or origins, and then we have this origin callback function that checks whether the origin is in that whitelist and only allows requests from that whitelist. You can implement whatever kind of logic you want to whitelist origins inside of this callback. We don't have any need for this in our API, but it's good to know that you have the option. Now, if we go back to our terminal and restart our server, this time let's run npm run watch, so it automatically restarts if we make any changes. And we're not going to touch our client because we haven't made any changes to our front-end code. And in our browser, let's refresh our mission control dashboard. And in our JavaScript console, no more error. We can go to the network tab, and again, if we refresh, we can see that the planets request is succeeding, and our response contains our empty list of planets. If we check our headers, we can see, scrolling down, that the access control allow origin header has been set correctly to the address of our front-end site. In the next video, let's figure out how to populate our list of planets with the actual Kepler habitable exoplanets. I'm excited. Let's go. Welcome back. Before we jump into coding, I want to take just a minute to answer a question that you might be asking yourself. Why do we have our models separate from our routers and controllers? Especially when we already said that it's good to have related code together, which is why we keep our routers and our controllers in one folder. This is a good question to have. The reason is that we keep our routers and controllers together because they're always one-to-one. There's always a controller for a router that uses a controller. For example, our planets router directly calls functions in our planet controller. And that controller is only ever used by that router. But for our models, we might have many of them used in one controller. Maybe it's a stars model together with a planets model, and we're aggregating those pieces of data that we can access from those models into some sort of solar system controller or some other space-related grouping of stars and planets. And it's possible that our planets model might be used in another controller, maybe in one that deals with mission launches. And maybe our stars model is used in a constellation controller, we separate our models because our data doesn't necessarily match up with the collections and API endpoints and overall functionality that our API needs to support through our controllers and our routes. We might have many models being used by a single controller, or we might have one model that's used in many different routes, in different controllers. That would be the example where our planets model might be used in a solar system controller and also in a launches or a missions controller. In either case, our models and controllers are not one-to-one. It's often the case that the way our data is stored, say in a database, doesn't necessarily correspond to how our API and application need to access that data. And it's the controller's responsibility to provide the data in the way that our application needs, and not in the way that it's stored in some database. This is where our model provides an abstraction that can transform and shape our data to and from the form that it's needed for our API. So we can keep our planets model, for example, next to our planets controller. But as a general pattern, that doesn't make sense. We want to be consistent regardless of which data we're working with. And we want to be flexible enough to support new models that may or may not be one-to-one with our controllers and the routes that are tied to those controllers. So it's only our routers and controllers that will live together, and we'll keep our models in a separate folder. All right, I know that's kind of abstract, so let's put our knowledge of models to use and get some real data to work with. On to the next video. Welcome back. Right now, we have a lot of really great functional code, but no data. And the data is really where the fun is. So let's fix that. After all, we did all of this hard work of finding the most likely habitable exoplanets in our planets project. So let's use the Habitable Planets project code in our API. I'm going to take the Kepler data and move it into a corresponding data folder in the root directory of our server. So data, and moving over Kepler data straight into that folder. We can close that for now. And now I'll move over all of our code for this project, and let's move it into our planets model. So I'll replace the contents of our file here, of the planets model, with our planets project code. And we're going to adapt it so that it works as the model for our API, for our planets collection. Where do we start? Well, we need to export some data from this model. So we'll start with module.exports equals an object. And if we remember, our planets code had this habitable planets array, which is populated based on the contents of this Kepler data CSV file containing all of the potential planets that were observed by the Kepler Space Telescope. We use this CSV parse library to parse all of the lines, all of the rows in that file, converting them into JavaScript objects that are passed into this data parameter, which we then check for our habitability criteria. So they need to be confirmed. The amount of starlight they get needs to match our criteria, and the planetary radius can't be more than 1.6 times Earth's radius. If our planet matches those criteria, we move it into this habitable planets array. And that's what we want to return in our planets controller from our planets endpoint. So, before we forget, we need to install that CSV parse library and add it as a dependency of our project. So in our terminal, our app crashed. That's fine. We're in the process of changing things. So I'll close the server that's running in this terminal, and let's npm install csv-parse. We're making progress. Okay, so now we can parse our CSV file successfully. And we can't forget over here to export something. I almost forgot. So we're going to take this habitable planets array, and we're going to rename it. We're going to set this property that's just called planets to the values in that habitable planets array. Because for the purposes of this API, all the planets we're working with are potentially habitable. NASA has done the research and is only willing to send rockets and missions to the most likely candidates. After all, we don't want to go to the wrong planet when the journey takes quite a few years. Our code should now be pretty close to working. We haven't tested it, but before we try things out, we have a bit of a conceptual challenge here related to the asynchronous behavior of our planet's code. Can you guess what it is? We're using streams. And Node won't wait for any of our stream code to complete before it returns our module's exports down here at the bottom. Let's really understand what's going on and learn how to deal with some very common Node stumbling blocks in the next video. It's going to be a juicy one, so I can't wait. Grab some coffee, grab some water, and I'll see you very soon. Welcome back. In this video, we're going to learn what to do when we need to populate our server with data on startup. A very common task in Node servers. While we're at it, we're also going to learn a lot about working with asynchronous code in both JavaScript and Node. Let's get on with it. What was that challenge that we ran into with our planets model? Our planets data is loaded and parsed as a stream. All of this happens asynchronously. We tell Node to start processing our file, but we don't wait around for it. Our module exports the planets before they've necessarily been loaded. And this all happens the first time our planets.model.js file here is required. All of the code in our Node module here is run when we require this module from our planets controller right here. And when Node sees this require statement, it starts running our planets model. Our planets data starts parsing asynchronously, but then our planets are exported and our controller can immediately start responding to the first request. And if that first request comes in from the front end to call the getAllPlanets endpoint, the planet's data might not have loaded yet. Our parsing code here could still be executing. So it's very possible that the front end will still get an empty list of planets even after all this work that we've done. No worries. There's a way we can fix this. We can create a JavaScript promise for our loading code. And we can wait for that promise to resolve before accepting any incoming requests in our controller. Remember JavaScript promises? We can create a new promise. Let's recap here by saying new promise. And if we assign this to some promise variable, we can then call promise.then with some callback function here that accepts the result of whatever code we passed into this promise. And we could then handle that in our callback. To make some code execute as a promise, we pass in this callback function into our new promise constructor. And this callback takes two parameters, a resolve function and a reject function. And if we call resolve in our callback, let's say resolve 42, then 42 is the value that's passed in as the result when we call promise.then. And alternatively, we could call await and await the result of that promise, assigning the result to the return value of our await call. And our code would now block for that promise to resolve before continuing, say before logging the result. Now, if you're asking, Adam, why are we reviewing promises in a video about planets and models? I know it's a little bit of a tangent, but this logic and the way that promises work is going to be critical for how we make sure that our planet's code is available when a request to get our list of planets comes in through our API. We're going to want to call this code as a function before handling any requests. So let's create a function that we'll call load planets data. No arguments. And for now, let's just move our stream code right into that function. We'll return a promise which resolves when our habitable planets have been found. And we'll wait for that promise to resolve before listening for requests in our server. Somewhere here, right before this server.listen function call. Let's do it. In planets.model, we'll return a new promise, which takes this resolve and reject function, and in the callback, we'll have our stream code. Let's make sure that the braces are all nicely aligned. We need to close our promise parenthesis right there. And we'll call the resolve function when we're done parsing our data and our habitable planets are populated and ready to go. We don't need to log our list of planet names. We'll instead be reading them from the API. So I'll remove that. And we're not passing anything into the resolve function to be returned when our promise resolves, because instead we're setting this habitable planets array. We're just using our promise so that we know when our planet's data has been successfully loaded. The one thing we will do is we'll use this reject function to reject when we get an error on our stream. Reject, and we can optionally pass in the error that we received. Now, depending on what happens in our stream, the promise will react accordingly. We're going to need to use this function when we start our server, so we'll export it just above our planets. And now in server.js, we want to wait for that function to complete before listening for and responding to requests. So we're going to add our long import here. Const planets model equals require, and with our path to /models/planets.model. Not too long. And in fact, we can use our destructuring syntax, so we know that we're using exactly one function from our model, which is the load planets data function that we're going to await so that our planet's data is available for any request that ever comes into our server. Await load planets data. And again, we don't need to use the return value for anything, so we should be good to go. Let's see if our front end gets the data from our CSV file all the way through our parsing logic, across our HTTP requests, and into our React front end. We'll npm run watch on our server, and looks like we missed something. Of course, await is only valid in an async function. One of the limitations of using common JS modules and our require function as opposed to the import syntax and ECMAScript modules is that we can't call await at the top level of a file. It needs to be inside of an async function. Luckily, there's an easy way to solve this. We'll create a function, say start server, which is async, and which loads the planet's data, and then starts listening on port 8000, or whatever our port has been set to. And now we can call our start server function, which will wait for the load planet's data promise to resolve before starting this server.listen call. And we don't have to await our function because nothing happens after we start our server. That is, a lot happens, but it's all in this function. There's no code that relies on start server having already completed below, right here. What we have here with our start server function is a very common node pattern that we can reuse whenever we need to load some data or perform some actions before our server actually starts responding to the user. It might be that we're setting up a database or downloading some files. Maybe we're checking that some services we rely on are available. Whatever it is, we might await it like we're doing with our load planets data function. So let's give this a go. All right. We got another error. It looks like we passed in the path to our CSV file incorrectly. That was careless. We should have double-checked that we're loading the right file. So we're going to use our path module, const path equals require path. And let me move my built-ins right above this third-party library. We're going to be using the path module just like we do in our code whenever we are looking for a relative path. It's going to be path.join _ dirname for the current folder that our planets model is in. And we want to go 1, 2 levels out into our server directory. So it's going to be ... and into our data folder, which then has our Kepler data.csv. All right, third tries the charm, right? Let me just clean up this comment over here. And moment of truth. Oh no, we've made too many changes without checking our code. Line 33, we forgot one of our closing brackets. Let's see. That's right, our path.join needs a closing parenthesis. So now we have 1, 2 closing parentheses and 1, 2 opening parentheses. All right, fourth try is the charm? Let's see. All right, our planets are being loaded before our server starts listening. Let's make sure our client is running. So far, so good. Let's make sure our controller is returning the correct thing. Our planet's model is actually returning an object with a function and our planet's array as well. So we actually need to destructure our planets from that object before we return it. All right, and our server has restarted. Let's look at our dashboard. What does our launch page contain? There we go. We have our destination exoplanets, all 8 of them. And we can select them as well as a mission name, which means we have all the data we need to start launching missions. Next up, let's find out what it takes to launch a mission in the backend. But before we go, starting from node 15, there's also this built-in Streams Promises API under the Stream/Promises module. This is built into Node, and it automatically converts streams to promises. Just a little tip in case you'll be working with streams and promises a lot in production. This might be worth a look. But we've learned a lot in this exercise by making mistakes and seeing how the asynchronous behavior of our functions can affect the values that are returned from our API. We now have the tools to switch back and forth between streams and promises depending on how we want our code to behave. All right, if you made it this far, congratulations. Let's take a well-deserved break, and I'll see you soon. Bye for now. Welcome back. We have a full-stack application with 2 folders and 2 npm packages that we need to switch back and forth from. One in our client and one in our server. For example, to run our NASA project, we need to first run our backend API by changing directory to our server and running npm start or npm run watch. And then, in a different terminal, we need to run our client with the front end by changing directory to the client folder and running npm start. This isn't very convenient. Let's make our life a little bit easier. Back in our VS Code, If you were really paying attention earlier, you might remember that I mentioned our NASA project will have 3 package.json files. One for the client, one for the server, but then one at the root of our project. And we'll use this root npm package to manage both the components of our project, so we don't have to switch back and forth all the time. What we'll do is, for now, terminate this client over here, clear the terminal, and go back up to the root of our project. To create our root package.json, we're going to run npm init-y, and this is going to be a package just like any other. Except this package won't have any of its own node modules or any dependencies, at least no dependencies other than our client over here and our server. So let's go into our package.json, and rather than npm installing, we'll write some scripts which will help us automate some of these common tasks that we have. Tasks like running the server first, and then running the client, which can talk to our server. So our goal will be to have a root watch script that we can run to watch for changes in either our client or our server, have both running at the same time, and restart the server if there's any changes. Sounds like a lot, right? But we're just using the tools that we already have, and we can break things down to make it a little bit easier. So for now, I'll keep the watch script empty, and I'm just going to create a script for our NASA project package.json, which will run our server. And what we could do here is we could change directory into our server folder, and then run this and or double ampersand command to both change directory into the server and run npm run watch in that server directory. You see, our scripts in our package.json run in our terminal using our shell, something like PowerShell on Windows or Bash on macOS and Linux. This double ampersand symbol is supported by effectively all shells on macOS and Linux. And on Windows, CMD, our command prompt, and versions of PowerShell above 7 all support this syntax. So if you're on Windows, make sure you're running PowerShell 7.0 or above, which, if you're using a recent version of Windows, should definitely be the case. And now we're clear, regardless of who's running our code, we should be in the clear for using these operators. This will run change directory to the server, and after it completes, it'll run the second command, npm run watch. So we can test this. Now in our NASA project folder, we can run npm run server. Oops, and we can tell it's working because there's a conflict with the port that's already in use in my other terminal, port 8000. So I'm going to go into our previous terminal, which we won't need anymore, and I'll shut down the node server running there, and now we can try again. There we go. We're starting our server from the root of our NASA project. All right, so now we need to do the same thing for our client so that we can then run our client and server side by side. So we can do client, change directory to client, and after that completes, we'll do npm start, And create React app, which is run on the start command, also includes functionality to watch our files for any changes. This is an approach you'll often see when running multiple commands in npm scripts. But there's actually a better way. Instead of doing this changing of directory and using our fancy symbols here, npm provides this npm -- prefix argument, which we can pass in to tell npm to run a command in a different folder, which we specify afterwards. So npm prefix server, and we'll pass that in actually after our run watch command. So we can do the same for our client, npm start -- prefix, and this time we'll run it in the client folder. This is a nice little shortcut that sets npm's prefix, which is the folder that npm will look into for your package.json with all of the commands that you want to run. If you don't set this prefix argument, we get the behavior we always expect, which is this npm start command will run in the current folder, in the root of our NASA project. So do you believe me? Let's try running our server using our new syntax. npm run server. There you go. Now, how do we implement our script to run both of the commands we just wrote? We want to do npm run server first to run this server script in our current folder from our package.json here. And then we also want to run, maybe using our and operator, the client script, npm run client. So what happens now? Let's try running our command. npm run watch, and our server starts, but we can wait however long we want, and our client will never start. What's going on? Well, remember, our double ampersand symbol here waits for the first command to complete before running the second command. And our server never actually exits. This command never completes until our server shuts down. So we're going to need a different approach. And luckily, it's just a one-character change. We just remove one of these ampersand symbols. Now, instead of running the server and waiting for it to exit before running the second command, our terminal will run this first command in the background, and then it runs the second command. So they'll be both running side by side in the same terminal window. Let's see what this looks like. npm run watch, and our server is running, and our front end loads as well. We can use this very same approach to automate any tasks that use both the front end and the back end. Say, for example, running any tests that we have in both, one after the other. So we could do npm run test -- prefix on our server, as well as, after that completes, doing npm run test -- prefix on our client. Or if we wanted to install the dependencies for our project, well, we could have an install - server command, which does npm install on the server. Let's do one for the client as well. And we'll put both together so that we can install our project as a whole. This time we'll run npm run install-server, and after that completes, npm run install-client. In this case, it's not important for both to run at the same time because our computer will install all of our dependencies for both as fast as possible before we can run our project. And now, our project should be a lot easier to work with, and our lives as developers will involve a lot less switching back and forth between folders and getting confused which terminal we're in. So let's demonstrate the npm install command. I'll terminate the client and server. Let's clear the terminal, make it nice, and npm install first runs any installation that we need to do for the server right here. And then, once that completes, we install any missing dependencies for the client. And we can see that npm created this package-lock.json for the root of our project, which just stores the version that we're working with. And just a little unrelated cleanup. In our client, let's take this gitignore file that lists common files that we don't want to track in our source code repository. For example, we often don't want to track our node modules because they're managed by our package.json files, and they tend to be quite large. So let's copy this file into our server as well, so that VS Code won't keep telling us that there's thousands of files that have changed because our node modules were updated. And it won't highlight our node modules folder in green as well. Much better. We can now manage our front-end and back-end code as one project. And we've learned quite a lot about scripting npm to make our life easier. I'll see you in the next video.